Hello, my name is Achfar Sadat Khan, and the project we have done is 10-bit custom RISC-V Microprocessor. And here in our project, we can see the files, the main file, the 10-bit register file, 1-bit ALU, 10-bit ALU, and we have also done R and I type data files. So now in our front, we have the 10-bit register file. Here we can see that this is a 10-bit register file where we have 4 register files of 10-bit. We have the input for write data, and now we are gonna do the operations. So this is the 1-bit ALU, and we can see that we have done quite a few operations here. The first one is for AND operation, or addition and subtraction. So now the first operation is the AND operation, and for that we are gonna take the inputs in the select bits. We can see right here. It will be 0, 0, 0, 0 because we are going to do the AND operation. Now we are going to the main file, and we can see that we have the ROM on the left side, the ALU on the right side in red, and in the middle we can see the register. So what we're going to do here now is we are going to take the values in the ROM. We can see it is a 4-bit value. It is currently on 2, 0, 1, and 2, but we are going to change it according to our operation. So we know that I'm going to do AND operation, and for that we're going to take the opcode as 0. So we have made it 0, and the second one is for RS, the third one is for RT, and the final one is obviously for RD. So what we are going to do is we are going to take 2 register and do an AND operation of their values, and we will make it we will take it and store it on the other register. So here we can see the lines that goes to the ALU. So we are going to do AND, and we have taken 0 as opcode. We are going to use the values of register 0 and 1. So for RS and RT, we have taken 0 and 1, which will be stored in read register 1 and read register 2. The opcode will go to the ALU in the operations. And on register, we will be having AND operation as read register 1 and read register 2, and the value of it will go to the write register, and hence we will get the result of the AND operation. So everyone, I have showed how I have done the AND operation, and my other group mates will show you how they have done the other operations, which were OR, addition, and subtraction. Now let's go and see them.
Hello, my name is India Abdul Hussain Khalid. I am doing OR operation. First of all, I made 1-bit ALU. By using 1-bit ALU, I made 10-bit ALU, and then I am doing OR operation. OR operation is arithmetic operation for, so I need to R-type operation, and this is the R-type file. This is the main file of the logisim. It is a 10-bit ISA design. I'm going to show you OR operation. I set OR operation 0001. I'm going to set OR operation 00001. Now, when OR operation output is stored in ROM, the input came from operation is this register. OR operation register is S2 S3. This is S2 S3 operation. OR operation is showing OR operation in and opcode. Opcode is stored in 8 and 9. RT file. Control unit signal ALU and register, and ROM is mainly doing restore the instruction, and RAM is do memory write and memory read. type operation we take 4 bit opcode, 2 bit RS, 2 bit RT, and 2 bit RD. OR operation we set R2 equal R, this operation opcode is set 0001. Or operation, it does or of logical operation between two register and store the value in a destination register. Operation D equal D plus S, and syntax is R or operation $RD, $RS. For 4-bit register, S4 register name S0, S1, S2, S3, and their values is 0. We use in our logisim two type of open, register open and immediate operand, and this is the value table for control unit. We in our logisim we had 6 operation. We did 6 operation. We use 4-bit or opcode operation and 2-bit extra operation. 2-bit bit is extra shift amount. This is my assembly file.
Assalamu alaikum, sir. I am Samin, sir, and I'm going to show you how the subtraction operation is going to work. We have chosen to put the register S0, S1, S2, and S3 as the values 00, 01, 10, and 11. And for the subtraction, we have choose the fourth operation of our ALU, and the selection bit for this subtraction operation is going to be 0011. Now for that, if we choose, if we consider this input subtraction S1, S2, and S0, the opcode for this one is the 0011. This one is 01. This is 02, and this is 00. This is 10, and this is 00. Now we have given the decimal values into the ROM for this operation. As we can see that the subtraction is 0, 2, 3, which is the fourth number, so the fourth number, then the resistor 1, then resistor 2, and resistor 0. Now the opcode if 3 number or the 3 is this one, and the opcode is directly given to the ALU. Now this one is the RT, which is the 0 resistor. This one is considered as RT, and this one is RS. Now this resistor, read resistor 1 or RT, is going to read the data from the resistor and will give the first input of this ALU. And then read register 2 is going to is the RS, and it is going to read the data and then give the data to as input 2 of the ALU. And according to the operation, the operation is going to happen as input 1 minus input 2, or input 2 as input 2 minus input 1, and then give the output, and this consider this wire, and this data will be stored into this register section, this write data and write register. If you consider the main data path, we have done the same thing. We have given the value, the instruction for the subtraction and in the ROM, and the for archetype is going to be chosen again as this opcode is going inside the operation of ALU. Then this one is RT, and this one is the RS. And then in here we have to use a mask where we are going to decide if it's if this one is the immediate value or RT. Now we're showing you, I'm showing you here R-type subtraction. So here we are going to use a switch and then use the perfect input for R-type, or as it is for R-type or I-type. Then Now, if it's the immediate value, if we choose the immediate value, then we are going to use an extender and convert it to 10-bit and use the marks and use it as um, the second input for the ALU, and then the operation is going to happen again. Then as given operation, which is subtraction, then we are going to use this RAM and store the value, and then we're going to decide whether we want to uh, write the data from the RAM, or we are going to write the data directly from the ALU, and we are going to use that choose that from using an ALU. Thank you, sir.
Assalamu alaikum everyone, this is Sheikh Najibur Rahman. Now I am gonna explain how add operation occur in 10-bit custom RISC-V microprocessor. At the beginning, we have to understand the register file and ALU circuit. We have built our 10-bit register file here. By using this register, we can store any value or take any value from here to perform an operation, and our 1-bit ALU is here, and it can perform 4 operations, and this is our select bit. Our select bit is basically our opcode. By using this 1-bit ALU, we build a 10-bit ALU circuit. Now in the main processor, we have to put instruction in ROM. The first bit of this instruction is opcode. This one is opcode. The second bit is RS, the third one is RT, and the last one is RD, which is the destination of our result. Read register 1 and read register 2 will select RS and RT register, and from this register data will go in ALU as input 1 and input 2. As our opcode is 2 here, so we will perform add operation, and as our opcode is 2 here, opcode is 2 here, so we will perform add operation and output will store is as our input is 2 here, so it will perform add operation and output will store in the right data, which is RD. And if you want to perform I-type operation, then we have to put the value. We have to put a constant value in the rightmost position of our instruction. Then RT and RS will perform the add operation, and it will be stored in RS register. The constant value of our instruction will go as a input 2, and the third bit of our instruction is the RS value, which has already a value, so they both will perform an add operation and the output will store it in the right register. And this is how the R-type and R-type I-type operation, and this is how I-type and R-type operation perform.